15 seconds. Good luck.
Hello. Am I audible?
Yeah.
Okay, so my name is Ganesh and I work as Senior Principal Software Engineer for Red Hat. So today I will talk about adding language support in editors using language server protocol. So what are the features traditionally you look for in editors? They are code auto-completion. So basically when you start typing in your editor, it should auto-complete with all the possible inline suggestions. Then go to definition. If you do a right click and want to see where this particular function is defined or where what is the documentation for this particular API, that's the go-to definition. Then if you hover on particular keyword, if you want to see the short description of what is being defined, you can use the documentation on hover functionality. Then there is this diagnostic functionality wherein when you are editing the document, at the same time you would want to see what are all the problems that are faced by the, what are all the problems that are in your code. So traditionally, to implement these features is a significant amount of effort. And in case, if you want to support it for each of your editors, the editors are implemented in different languages, and all those editors have different APIs. So to provide a programming language support for a single API, single editor, you would have to implement different programming specific languages. So in this case, let's say I'm picking Python here. So I have to have one implementation for VS Code, another for Sublime, another for Vim. And that is not the most optimized way how you would like to do things. So in comes the language server protocol. This protocol was developed by Microsoft Visual Studio, and it was standardized. It was published in 2016, and it was standardized over time in collaboration with Red Hat and CodeEnvy. The protocol is an open JSON RPC based protocol, and that is used to communicate between the editors and the server. So the server provides the programming language specific features, and the goal of the protocol is to implement the programming language support and distribute it independently of any particular IDE. So in this diagram, you can see that there is only one implementation that provides all the features that I mentioned in the first slide, that is completion, diagnostic, hover, formatting, and all the on the left side there are the language server implementations, one for JavaScript, one for Python, one for Java, and so on. And the editors that understand the language server protocol can use this single implementation to communicate with the language server. And the implementation of the language server can be in any specific language. It is not dependent on what is provided by the IDE. So this slide goes a bit into detail about how the communication happen. So when a development tool is basically your code editor, when the user opens a document, it sends a JSON RPC request. In this case, it will first send did open with parameters, information about what document is open in the IDE. Language server will store that information at its end. Then when a user makes edit to the document, it will send did change params, and it will send the doc URL. So basically the source of truth will not be in file system mode. It will be in the memory of the IDE, and that doc URL is being sent to the language server along with what is the changes that are done. Language server on its side runs some of the diagnostic information, some of the static analysis tool, and try to figure out any problem with the source code, and it sends the diagnostic information back to the IDE. And IDE basically then does the job of rendering that problems to the user in the editor. Then for go-to definition, similarly the flow happens. If you're working with different languages, so IDE will basically create an instance of language server locally in the background, and it will start sending requests to the right language server. So in this case, if you open a document for SAS or Java, it will send requests to that particular language server. This slide shows the language server protocol that we had developed for Ansible. The APIs that were developed were do, hover, do complete, completion, do validate, and do semantic. So this single implementation can be used by multiple editors, irrespective of which language they are written in. And right now we have clients for VS Code, Vim, and Emacs. So in this case, at the server side, we run Ansible specific utilities like Ansible config, Ansible doc, to introspect the user environment and fetch all the documents, plugin documentations that are there installed on the user system. And that's how we come to know whenever a user sends a autocomplete request, we get the completion inline suggestion. So yeah, thank you.
Next up, Mathieu.
Mathieu, yeah.
Are you ready?
Maybe you can.
Oh yeah, maybe we can.
I'm a big tall.
Or just take it out.
Oh, it should be alright. This way.
Yeah, so?
Well, I'm going to take it. Okay.
Okay, good luck.
So yeah, hi everyone. Thanks for being there to this Ignite talk, and thanks Config Management to organize such an event. This is super cool. Thanks again. Before starting, let me quickly introduce myself. So my name is Mathieu. I work as a Linux OS software engineer at Microsoft, mainly involved on Flatcar development. Flatcar is a Linux distribution mainly oriented to run container workloads. Maybe you heard about it from CoreOS folks, so it's the legacy. So today we're going to talk about Ignition. So I think it is the best place to talk about Ignition in Ignite talk. So yeah, let's do it. One-time provisioning software. So why such a talk to start? Basically, the idea is not to say that Ignition is better than Ansible or Cloud Init. The idea is just to give you an overview of another tool, and for you to choose what's the best tool in your workload and what's the best tool that fits your needs. So Ignition configuration is a JSON configuration. It's mainly declarative. It means that you can't have dynamic properties defined into your configuration. It's simply a state that you want to reach into your system once it boots. So with Ignition, it boots or nothing. So you can't have an instance halfly provisioning. Basically, if there is an error during the provisioning, the instance won't boot at all. So this is pretty cool because it ensures that everything has been correctly provisioned. And with Ignition, it runs only once. So once the instance has been provisioning and correctly provisioning, it won't run anymore. So it's not like Cloud Init that runs at each boot of the instance. Then Ignition runs really early in the boot from the initramfs file system. So you can do really low-level operation like LUKS encryption, decryption, but also injecting or removing a parameter from the kernel command line. Then finally, it's a JSON configuration, but we recommend to use external tools like Butane to generate that JSON configuration, because no one loves to write a JSON configuration by hand. So you can use Butane, which this is an example of Butane configuration to generate Ignition configuration for Flatcar. So you can see that I just want to define a file in /opt/file with the hello world content. Once I have this file, this configuration file, I can easily transpile it to an actual Ignition configuration. So this is the Butane command line, and then I have my JSON configuration file with Ignition version 3.3.0. And you can see that my hello world has been correctly changed to a data source. Then I can simply run the Flatcar instance using QEMU, and the configuration, JSON configuration, will be loaded at the boot, and you can see that my file has been created. So nice, it runs locally with QEMU, but how do I deal with cloud providers? So Ignition supports a bunch of cloud providers, GCP, Azure, AWS, OpenStack. As long as you can have IMDS instance metadata service from the cloud provider, you can easily load configuration, JSON configuration at boot. So this is an example from the code base with Azure. So with Azure, you can define your Ignition configuration as a user data, like a Cloud Init one. And when the instance is going to boot, it's going to fetch that configuration from the user data from the IMDS. This is an example of Flatcar, because with Flatcar we got that issue with backward compatibility. As you've seen, we can have Ignition version. So this is currently the Ignition 3.3.0 that's supported, but we wanted to ensure Ignition 2 also supported, so we tried to implement some translation mechanism. So we have to carry a couple of patches that we try to upstream to the Ignition repository. But yeah, this is just a short overview of how does it work with Flatcar. and how do we try to keep backward compatibility. So it's up to the distro maintainer or to the user to install Ignition into the initram file system. So you need to be sure that you pull all the system dependencies into the initram file system. For example, here we can see that crypt setup is needed for Lux encryption and decryption. And here's a few of distribution that does support Ignition, so Flatcar, Fedora OS, but also Micro OS. And I've seen on Ubuntu that there is the package for Ignition, so you can try it. And since we have the config management camp, I wanted to mention that you can also use Terraform to inject Ignition configuration, so everything in the same code base. You can have your Terraform deployment and also your Terraform provisioning with Ignition. Here, a couple of resources if you want to dig further, the documentation and the Flatcar documentation if you want to try out with getting started. And finally, my Fastodon handler if you want to ping me on ask questions or stuff like that. Thanks again.
Felix? We're still on time.
Yeah. Hi. So great to be back in person in Ghent Config Management Camp. Or as a friend dubbed it when I explained the structure of the conference, you're basically in Nerdistan. And I like that. So welcome back everyone in Nerdistan, fellow Nerdistanians. Some of you may wonder, wait, this is main stage and someone's talking about Ansible and Puppet, what year is this? To which, look, those are bread and butter tools, so they're bare talking about, and this is Config Management Camp, it's YAML camp. So screw you, I'm Felix, I will talk about Ansible, hell yeah, and not only that, I will talk about a script that I wrote in Python to connect Ansible to my Puppet installations. So again, some fellow Nerdistanians may say, wait, why would I bother writing Python when there's GitHub and I can get a dozen open source implementations of that shit from there? So yes, thank you. I have heard of GitHub. I have reasons, and I will start at the beginning. So a lot of the time, Ansible can look like this when you try to use it, right? You fire off your playbook, but then boom, you're on a new system, or you're provisioning new systems, and nobody knows anybody else's SSH keys, and then your screen is full of annoying warnings and questions because, yeah, SSH keys. If you look at the UX of that, it's pretty clunky, right? If you don't have proper public key infrastructure, then yeah, how do you provision it? Well, when nobody's looking, I just run SSH key scan through my entire inventory and build a known hosts file, and then it just works. But this is basically the same thing as just disabling the checks. So security, So what if I tell you, if you run Puppet the whole time for whatever reason, then you probably have PuppetDB. And along with Factor, that is in Puppet, you basically got a free PKI, because Factor keeps collecting all these SSH keys and putting them in a database. And since I'm writing this Python script for my Ansible in the first place, I might as well get the keys from right there. And it's fairly easy. So PuppetDB gives us this HTTP API, and with a very simple curl, in this case I got all the keys from one certain type. I get one JSON document. It has all the keys with the names of the machines attached. In this case, I got about 500 of them in this PuppetDB. It took 2 seconds, which is a long time. I have a lot of overhead in the way that I conducted this experiment. Usually, you can build the full known hosts stuff in under a second for, I think, a pretty much larger infrastructure. And it's fun, it's cool. Another thing that I want my Python script to do is not just give me one huge list of machines that Puppet knows about and give me one big Ansible group. I mean, this is already useful, it's powerful, I can do a lot of damage with just having all my hosts in one Ansible group. But the thing is, in PuppetDB, there's a lot of additional information about all your machines. So you can derive some structure from that. For example, you may have custom facts already that tell you, all these machines are production, and all those are testing, and then that is UA. And another fact might tell you, yeah, this is in project X, and those are in the project that is totally not going to be a Death Star at some point. Problem is when you get all your facts from PuppetDB, even if you just have 500 machines, it's a lot of data, it takes time. Something else you can do is just query resources. So with this query, it's a little more involved, but I got all the classes that machines declare that start with profile : The Puppet enjoyers in the audience know what I'm talking about. And it's a little more flexible, it's more elegant, it doesn't require so much data, but it's still not quite as flexible as the fact thing, right? So I took a middle way. I invented this resource type with a very simple code. It's guaranteed bug-free, by the way, 0 unit tests required. And I can just create a bunch of resources that give me the same information as those custom facts. You know, now I have a resource that tells, yeah, you are a staging machine, no, you are a production machine, or you are in that project. And I can have as many of these aspect resources on any node as I need. And this gives me all the control to get an Ansible inventory out of my Puppet data that has the exact shape that I want, and I control it all through Puppet code. So yeah, those are the two ideas I just wanted to put out there. Maybe it's interesting for someone. Mandatory message from my employer: we are hiring, so yeah, find me in the hallway. If you know someone who is looking for a job, talk to me about jobs, talk to me about anything, get a free hug. It's nice to be here. Thank you for listening.
Get the next Docker one.
That one. Yes.
Good luck.
Cool. Yeah. Hello everyone. I know you heard about some NICs yesterday, and now I will share an unpopular opinion about why you would prefer it over Dockerfile or a lot of different configuration format. To recall you, what's NICs again? It's package manager, configuration language, and OS. But most importantly, it helps you to describe developer environment or package as a complete list of its dependency. Like, I mean, all your dependency. By complete, it will fetch and locks everything you need. That means you sure your package, everything you need to have your package is in control, so that's a way to assure you reproducibility, and that helps you to have, for example, 2 conflicting glibc versions on your machine. It could work. That's not an issue when you use NICs or 2 Python version or anything, and that's work with something called patch elf that will force binary to use the specific dynamic library you want it to use. That's how NICs assure you to control the complete set of dependencies. So the guarantee is one NICs file when it's hermetic, guaranteed by the flex feature for the details, means your reproducible developer, a perfectly reproducible developer environment. It's guaranteed. So it's really cool guarantee. And if we want to have some code example, here I set a hash where I say this version of NIC package, so I'm sure I will always have exactly the same version of Python 3 in every, I know, it's guaranteed. And if I talk a bit about Docker, you will say, yeah, I know I will have the same guarantee, but I want you to ask yourself, are you sure? Is it true if you use, for example, Ubuntu? Is it true if there is some other command hidden? I don't know. And the thing is, with a Docker file, you can generate 2 different images. So the same Docker file run 2 different times may produce 2 different images. You don't know about that. You have to trust the Docker file, and maybe someone else written it, so you don't know. And the thing is, you have to keep track of Docker file and under Docker file, and this is really hard, and bad practice is a bit like you put binary in your Git source repository. You want to handle source nodes Docker, so you can use NICs inside Docker. And if you use NICs inside Docker, there is a NICs Docker image. you can have a Nix environment and you have everything reproducible. So an example will appear in a few seconds here. And it looks like that. And if I do that, I know I will have the right Python version. But I get the same issue I just said before. I don't know if someone do weird things in my Docker file. I have no real guarantee. I have to trust the Docker file. And the image is really big. And Docker image could be changed, mutated. So sometimes nobody really know what's all the steps to produce an image, because we care about image, not source. It's a bit like nobody know how to build a package. And there is a cool thing about Nix is we can generate Docker image declaratively, like we write it as a Nix package. And the really cool thing is it will not include Nix or any package manager, just the package you defined to be inside of it. So you can have something like that. I just say, I want Python 3, and I hope it will work well. I miss the version things, but you get the idea. And if I do that, I know I couldn't do something non-reproducible, and I have a nice side effect, which is I have really small images, because I only bring in my images what images does, what images use to build themselves. So it's really cool, and Nix have a lot of features like stream the layered image and anything. And the thing is really hard actually to, if you have an existing Bing Docker file written by something else, to turn it into a Nix expression, because it's two different models of thinking, like a step-by-step declarative one to an imperative one. But I try to work around this on my free time. So if you're interested in to have an idea how to test a class that's help to do that, feel free to ping me. That's not the last slide, it's the trick. The thing is, I just want to convince you that it's really more easy to contribute to Nix package than, I don't know, any other Linux distribution, Arc, Debian, or... And the tool used by this slide isn't supported by Nix package, because no one wants to support Python 2. So feel free to contribute. Yes, there is a really bunch of contributors around Nix package. It's a really cool project to send a package to. So thank you a lot for your attention.
Basically saying you can't move to Nix first. Or you would not be able to run your slides next year.
That's too bad for Brian then. Now I really have an argument. Who's seen the previous version of this talk?
So hi, I'm Bram, and this is my website, and we're gonna talk today about how deep down the rabbit hole you can go in setting this up. New kids nowadays would call it the challenge, and this is basically a question posed in a bar. And so we're going to build a one-page website, right? It's going to be marked down just what you saw. It's an image. It's a link to my GitHub and my Twitter. So nobody writes HTML anymore. I can't. So I used Hugo to build it into an HTML page. Browsers nowadays, they refuse to load anything that isn't HTTPS anymore. So I need to get a free certificate from somewhere, because that's what I call this version. I've done the Hold My Beer edition, and this is the free stuff edition. So HTML, we need to serve it with something. So we're going to add something called Nginx, which is a very nice web serving tool. Currently part of F5 even. Right, it needs to run somewhere. On my Mac, it's ARM based, so that will run now nowhere. So I need to, Docker, because the people that still know Java, when that came out, they sold us build it once, run it everywhere. Right, so I need to run it. It's in my Docker container. I can't ship my laptop to the data center, so I need to have a data center. And this is the one where you go like, hey, hold on, Bram, this is not the free version. That's right, but I'm Dutch, I'm cheap, so I prepaid for an AWS instance for 3 years. So at this point, it was free, so it could land on there anywhere. So, of course, my original plan was to do a blog, and it's going to be very insightful, and it's going to have lots of visitors. So we're going to add a load balancer so that eventually, it can scale to AWS, right? That started to become very complicated. So I had my Docker that needed to run. I had my load balancer, so I started puppetizing things, just like Felix did. Puppet is my tool of choice to build the OS. That started to be complicated because I needed to preload this Puppet thing onto my EC2, because who can be asked to write a shell script to cloud init? I pre-built it in Packer. It also loads it very quickly. That added another layer of complexity. So we're going to terraform the AWS, right? We've automated our OS, but we need to automate our cloud. So Terraform came into the mix. I can run this for free because I can basically Terraform Cloud has a free offering. Right, when we're going to scale, it's going to be amazing. Then I can't be asked to hard code IP numbers again because in the cloud things go away, come back. So I added a layer of service discovery, and then we end up on a service scheduler because friends don't let friends run Kubernetes. So I chose Nomad. So I can just dump it on any of the nodes, and traffic can ask console where my Nomad nodes live, so it's all cool. The auto-scaling again, right? It's still Nomad because they luckily came out with a tool, right? I can now add multiple instances, so all the visitors can get like a nice, crisp, quickly responding answer. Even if it explodes, it has an AWS auto-scaling support. Right, at that point, it became very complex. It had multiple tools, multiple files. So, get some CI/CD into the mix because I can't be asked to run this myself anymore. Just commit and then have my tools do it. I got very interested in supply chain attacks at that point. Because my blog is going to be so insightful that I'm now an attack vector. So I started looking into my repositories. Docker, AWS Docker doesn't do secure images. At the same point, my SSH tunnel is going to be an attack vector, so I'm going to stick something in like boundary or a teleport. That still requires me to create an SSH key that might leak somewhere, so I'm going to add that in Vault, and Vault has engines that can generate these things for me, so it's just a throwaway image or something. It's going to be complex. All these visitors, I've built it auto-scaling, but it could still go down, so we're going to have some observability. We want metrics, we want logs, we want to see how many people actually come to see my insightful stuff. At this point, the blog's still not there, single page. But I do have metrics, so metrics are fine. But if nobody looks at it, we need some alerting. So I'm actually have PagerDuty and Slack support. So when my website goes down, it does nothing. I get a pager. And this is the end. This is the last slide. Basically, say I had loads of fun building all this out, but don't be me. Just stick it on GitHub pages and be done with it. Thank you.